So I have a list. Now I want to iterate through a slice of it. Okay. So for that I have a function islice. Now first argument it will take a list through which I have to iterate. If I just specify the two arguments, the second argument will be the end of it. Okay. So I'm saying print value. Okay. So this is my itertool.islice function. So it will be useful. Yeah, yeah. So islice will be used to iterate through a slice of this. Okay. What I am saying that so islice take two arguments. First is my list, and second is the index of the endpoint. Okay. So first will be the iterable from which you want to iterate. I'm specifying iterate through this list. Okay. Second argument I'm saying endpoint. Okay. Now 0, 1, 2, 3, 4, 5. Yeah. Okay. If I just provide the two, defaultly it will start from the first and second it will consider as a end. Okay. Again, my end is not increasing. 0, 1, 2, 3, 4, 5. Okay. So till 4 it will be. Now if I put three arguments, my second argument will be the start. So start from this index, go till this index. Okay. So this is like iterating over the slice of the. Okay. Now this iterators can be your count function now. If you see that your count function is infinite, you cannot stop it, then in that case you can use your count here. Instead of this iterable, I'll say itertools.count. So I can specify the start here, right? So let's say start from 5, incremented by 5, okay, and stop at, let's say, 20th index. Now this will be 20th element. So this is the index. When I say I slice, it will be index based, not the value based. Okay? Yeah. Yeah. So when I say my count function, count will generate me infinite numbers, right? It will take two arguments maximum. If I do not provide anything, it will 0 to infinity, right? But I can provide start, so I'm saying start from 5, incremented by 5, right? Now I do not have method to end it, right? But I can use it with my islice function to provide an end to it. So my islice take first argument as a iterable, so my iterable will be my count function, right? Second argument, if I'm providing two values to my islice, my second argument is the end, right? Now this end, remember this is the index here. So we first check for reaching till 60, we specified 5, right? Same this 20 is the index.
But we don't have protein indexes.
Uh-huh. No. So now we are not talking about list. Now I'm counter. I have infinite indexes now, right?
So we are printing out 20 indexes.
20 indexes. Okay. So this is the way I can stop my count function using my islice. But main importance of my slice will be iterating through a slice of the list of tuple.
So what is the difference between slice and islice? Iterates it.
Yeah, slice will only, so if I see slicing, it will just give me the entire string, right? Exactly.
Here
it will iterate. Okay. So this is my islice. Now, in case of my all the normal list we have seen till now, so we start from here, we go till here, and we stop it here, right? What if I want to repeat? Okay. So for that, I have a function called cycle. What that cycle will do, that cycle will infinitely repeat through the list. Okay. I'm saying something like this. For the effect, let me reduce number of elements. Okay. No, I'm saying for value in Itertools. Correct. Itertools dot cycle, and I'm saying repeat this list. Now, if I just print value here, if I just print value here, it will go on an infinite loop, right? Just to avoid that, I'm writing, let me take one count now, and then we will use it with my islice function. Count greater than 20, then break, else, do this, and count, yeah, here we go. So I'll get 10, 20, 30, 50, then again 10, 20, 30, 50, 10, 20, 30, 50, like that. Okay. So if I put cycle function, it will infinitely keep on iterating over the iterator which you have specified.
Now compare to a printing the list or what?
No, no, so it's counting 20 numbers actually. So I'm maintaining the count variable. Exactly. So if you want to stop it, yeah.
The loops cycle returns
A single element, a single element. It's working the same. It's just once it reaches end, it's not stopping there. It's just starting from first again and again. Okay. So this is my cycle. Now let's say if you want to iterate through a particular list entirely. Okay. So here I'm getting a single element from this list, right? What if in each iteration I want the entire list? Okay. So if I use repeat, so repeat will infinitely give me the element which I have specified. Now this, so there is no restriction what that element should be. So if I just say repeat 100, it will give me 100. If I say Python, if I say list L,
so that repeat returns the complete list.
complete list, exactly, exactly. Now my cycle will take a single element and go on, but my repeat in each iteration it will return me the entire element which I have specified. So cycle will start iterating whatever right inside of here. So if I try to do the same thing with my cycle and I write Python here, right? Cycle. So for cycle, this cannot be integer. Okay. So this should be a iterable. Yeah, a tuple or anything, but cannot be integer and floating. So now if I say Python, so it will go on infinitely just cycling through this pyt. Okay. This is the Itertools last two functions. Are you good with probability? Good with probability?
No, actually.
How about your version?
I'm getting it, but I'm not sure why is it used.
Well, data science will answer this question for you.
Oh, okay.
You have to use
Yeah,
it.
Yeah, we can do these things using other existing logic or language constructs
Uh-huh.
quite easily, right? So
Yeah.
I'm not sure why we need a separate library for all this. Yeah, I think, like you said, we'll find out, I guess.
Yeah. Mm, last two functions, permutations and combinations. So I have something like this. Print Itertools dot permutations and so I'm saying from this list, give me all possible combination of selecting two numbers only. All right. Okay. So this will count with me all possible combinations 1, 2, 1, 3. Again repeating 2, 1, 2, 3. Right. On the similar line, I have function for combinations also. Combinations now here repetition will not be there. So my 1, 2 and the 2, 1 are same. So I'll only get one element 1, 2, 1, 3, 2, 3. This will go back to your mathematics probabilities concept. Okay. But in case if you need them, Python provides a function for you. So based on your use cases, you can use these functions. So yeah, this Itertools library is completely optional. So the way we are doing it, it can be done using my normal for loop also. It provides part of inbuilt function for me, and I can just directly use it. That's it. Okay. So this is my functional programming. So we'll stop here. Okay. From next class, I guess we can wind it up in next 2 days, in next week. Let's see. So topics we have decorators, then XML and JSON parsing, then threading, then socket programming, web scraping. I don't think web scraping and the database. I guess we will need 3 classes more, not
Yeah,
2.
maybe one plus questions.
Okay.
Or maybe so just want to understand here how we can create an application or like is it covered part of it
Which one?
just any application web
Mm-hmm.
application
Mm-hmm.
how we can
So
how to
creating
create
a separate model in our
like a process thing
okay,
and even if it is a library how we
Mhm.
can create a library
for our own
like a extension to libraries
Mhm.
process
Sure.
something like in Linux we call demand.
Yeah.
The similar
Yeah,
concept.
yeah. All right then.
Kunal, I have a question.
Yeah.
When you say functional programming, right? What
Mm-hmm.
exactly are you talking about? Is it only Lambda functions or all these ITER tools,
All these things,
etc.?
all these things. So mainly lambda, map, filter, and list comprehension.
Okay. ITER tools, for example, what makes them to be related with the functional
No.
programming?
Itertools is different. Itertools is a different. So it will not be the part of functional access.
Okay.
Okay. Map, lambda, filter, and my list comprehensions. On the same way, we have set comprehension, dictionary comprehension, all this.
Okay, got it.
Generate the
Yeah.
Generate.
Okay then, guys. See you next week.
All right. Thank you, Kunal.
Yeah. Thank you.